Have you ever wondered why radio signals can easily pass through the walls of your house, allowing you to listen to a radio station indoors, while visible light cannot pass through the same walls? If light is also an electromagnetic wave, why is it blocked by bricks, but radio waves are not? To answer this question, we first need to understand the electromagnetic spectrum. The electromagnetic spectrum is simply a collection of all types of electromagnetic waves arranged according to their frequency or wavelength. It includes radio waves, microwaves, infrared waves, visible light, ultraviolet rays, X-rays, and gamma rays. Although these waves have different names, they are all the same type of wave. The only difference between them is their frequency and wavelength. As we move from radio waves toward gamma rays, the frequency keeps increasing. You can think of frequency as how fast the wave is oscillating or wiggling. A higher frequency means the wave completes more oscillations every second. Therefore, visible light or gamma rays have a much higher frequency than radio waves. Now, in quantum physics, electromagnetic waves are not only treated as waves, but also as tiny packets of energy called photons. You can think of a photon as the smallest packet of light or electromagnetic energy. Every type of electromagnetic wave is made up of photons. However, the amount of energy carried by each photon depends on the frequency of the wave. This relationship is given by Planck's famous equation, which states that the energy of a photon is equal to Planck's constant multiplied by its frequency. Since Planck's constant is just a fixed number, the only quantity that changes is the frequency. Therefore, as the frequency increases, the energy of each photon also increases. Since radio waves have a very low frequency, each radio photon carries a very small amount of energy. On the other hand, visible light has a much higher frequency, so each visible light photon carries much more energy. X-rays and gamma rays have even higher frequencies, which means their photons are even more energetic. To understand why this matters, let us now look at what happens inside a brick. Every brick is made up of atoms, and each atom contains electrons. According to Bohr's atomic model, these electrons can exist in their orbits only in certain allowed energy levels. They can move to a higher energy level only if they receive exactly the required amount of energy. Now imagine a radio photon striking a brick. Since the energy carried by a radio photon is extremely small, it is not enough to excite the electrons inside the atoms of the brick. The electrons simply ignore the incoming photon because it does not provide the required energy. As a result, the radio wave passes through the brick with very little interaction. Now, consider a photon of visible light. The energy carried by a visible light photon is much closer to the energy required to excite the electrons inside the atoms. Therefore, when visible light strikes the brick, many electrons absorb this energy and become excited. During this interaction, the light is absorbed, reflected, and scattered in different directions instead of passing straight through. This is why you cannot see through the walls of your house. That is the fundamental reason why radio signals can enter your house, while visible light cannot. Like, share, and subscribe.